All right, hi everyone. We're gonna get started. My name is Julie Q, and I spend a lot of time working with databases. Many of you have probably come across the issue that I'm gonna talk about today, which is at some point, all of us need to edit data in production. And there's a lot of ways you can go about doing this editing, some of which are gonna be a little bit better than others. And today I'm gonna talk to you about the evolution of processes that I've helped develop at my company. Hopefully, some of the strategies I'm going to talk about are going to make editing production data safer at your organization too. So a little bit about me. I'm an engineering lead at Spring. You can reach me on Twitter at JQ25. For those of you who haven't heard of Spring before, Spring is a fashion e-commerce marketplace that integrates with thousands of different brands. The team that I lead is one of the ones that builds out our product catalog. So I think a lot about getting data ingested into our system. And so this also kind of means that more often than I would like, I found myself behind the SQL prompt needing to make edits to production. And after being in that situation a couple of times, I started to ask myself why. We all know that this is bad practice, so why do we all do it anyways? For me, the first reason is often because the internal tools that I need are simply not available. I would have used a better method, but we just didn't build it. The second is that I ran into an edge case. So sometimes we actually did take the time to prioritize that shiny user interface for our project, but it doesn't handle all of the cases that I need it to do. And lastly, sometimes I just need to make a time-sensitive change, and connecting to a remote database is oftentimes just the fastest and easiest solution. It's really easy to just get behind a SQL prompt and execute a SQL query. And usually, there's not really that much of a problem with it either. So let's say, for example, I want to run this query, which updates the products table and sets the name of the first product to Julie's product. And so I write this query, and before running it, I'm usually a little bit cautious, so I'll get people to spot check me. But let's just say this one time I need to run this query, and it happens to be Friday night, which is the best time to run queries. And someone comes up to me on the marketing team and is like, "Hey, Julie, I need you to make this change before the weekend. I promised this brand that we would change the name of this product, and if you don't do it right now, they're gonna pull themselves off the Spring platform, and they make us a lot of money." So I write the query, I look around me, and by the time I'm done, I realize that all the engineers have already left for the weekend. And so at this point, I'm like, oh, hey, I could Slack someone and get them to double check me, but it's also Friday night, and I really don't want to bother anyone. I lead the catalog team. I've done this a million times before. Y'all see this. This is such a simple change. What is the worst thing that's going to happen? So I go ahead. I run the query. I go and get some water before heading home for the weekend. I let the marketing team know that I made the change, and some people might have predicted, came back to my computer and realized this is what I actually ran. And for people in the audience right now who aren't familiar with SQL, I think people are cringing a little bit more than laughing because they all know that I accidentally updated every single product in our system to be named Julie's product. So before, I'm sure that some of us actually had disaster situations similar to what I just described. There were some very accurate predictions made in the audience. And the key here is that these things don't happen because we're bad engineers. They happen because mistakes happen, and having the ability to make any edit that you want sets you up to make this kind of mistake. So today, we're going to talk about some strategies to make editing safer at your organization. We're going to talk through 5 different strategies. These include strategies for maintaining a raw SQL spreadsheet, running scripts locally, running scripts on an existing server, using a task runner, and building a script runner service. We're going to walk through the strategies in the amount of upfront effort it takes for the strategy to be implemented at your organization. And we'll also plot them in order of the benefits that you're going to receive. For each strategy, we'll talk about 3 things: how the strategy works, what's great about it, and also what's not so great. And the examples that I'm going to use today will involve a Python stack, since we're at PyCaribbean, and a SQL database, but you can actually use them with any stack of your choice. So let's get started. The first strategy I'm going to talk about is relatively simple. It doesn't require any new code to be written or any infrastructure to be built, but rather it's about developing a process to do the double checking that you already should be doing. So what does this process look like? So let's go back to this query that I had intended to run for the marketing team. And what I had done a few slides ago was I just went ahead and executed it. We all realized that this was a dangerous situation to be in. So what we did at my company is we started maintaining a Google spreadsheet to record manual SQL queries against production. This Google spreadsheet lets us collaborate and review each other's queries before they're executed. And it also gives us a checklist for what we need to do before running a query against production. So this is what it looks like. The first step would be for me to add a row to the spreadsheet. So some information I would include in a spreadsheet would be my name, the date, description, and the query itself. And then I would also write down a reviewer who would then look at the query and either approve it or request changes. So in this example, my coworker Apachu caught that I spelled Julie wrong, and I'm going to go ahead and make that change. And similar to code reviews, after a couple back and forths, the next step is for the reviewer to go ahead and approve the query. And once you get those 2 thumbs up, the last step is to go ahead and run the query. In this step, we ask everyone to run their manual edits inside a transaction. That way, if they notice that they make a mistake halfway through, it's really easy to just go ahead and roll back. So what's great about this system? The first is that it's really easy to implement. You can actually just get this started at your company during the lunch break today. All you have to do is make a spreadsheet and send out an email and let everyone know what to do. But the effects of this simple process are really powerful. And this is because the strategy provides us with an audit trail. So after we implement the process, we went from having all of these ad hoc queries that we were hoping people were getting spot checked to actually having a record of everything that was getting run against production and who was running it. And this audit trail not only gave us information about who was running the query, but why they were running it, and gave us a lot of discussions about areas where maybe we should be investing in internal tools, or maybe we should just be overhauling an entire system and rebuilding it all together. And lastly, this process promotes the right behaviors. So for example, if you've been working with databases for a while, it might seem like common sense that you should always run your manual edits inside a transaction. But not everyone's going to know this who needs to run an edit against production, and certainly I didn't the first time that I was on call as an engineer. So having this process in place helps to not only encourage people to be careful, but actually teaches them what are the right things to do. And if we take a step back in this presentation, we're going to go on a journey to explore each of the strategies that I'll be discussing in terms of their benefits and upfront costs. So on the x-axis, we're going to be plotting benefits, and on the y-axis, we'll look at it in terms of the amount of effort that this strategy needs to be implemented at your organization. So right now we're here. We have a strategy that allows us to do data editing. We've also implemented a manual process for code review and for an audit trail. And this is really great because this is having to run raw SQL edits, especially at your average startup, is probably not going to go away. Up until this day, we still use this spreadsheet. But what's great about it is that we're now empowering engineers to avoid making mistakes by making sure that they get spot checked. So introducing this process also makes it just a little bit more painful for people to run queries ad hoc. And so it encourages them to build better tools. So what are some things we're not getting with this process? The first is that it's still kind of easy to make mistakes because after all, we're asking people to get reviewed. We're assuming they're copying and pasting it from the spreadsheet into the SQL prompt, but that might not be true, and even so, errors can happen. The second is that this audit trail is being maintained manually, so that opens up some room for error, because after all, there's really nothing preventing you from running an unchecked query. And sometimes we might be put in this urgent and unexpected situation where we might just skip this audit step. So let's say I'm on call and I get woken up at 2 a.m. in the morning and there's a production outage. I might feel a lot of pressure to fix things really quickly, and at which point I might just skip getting my query reviewed at the time and do it retroactively. But did I mention also it's 2 a.m.? That's probably when I'm most likely to be dropping that where clause. And lastly, with this strategy, while it's really easy to run something like update Julie's product, update product 1 to Julie's product, it's a lot more difficult to execute long and complex queries with raw SQL. So if your query takes a really long time to run, it's going to time out. For example, let's go back to this query that I wanted to run and get some more variations of it. So let's say that the marketing team didn't know that I needed to update product 1. Instead, what they said is, hey Julie, we have this brand called Julie's Store. Can you go in and update every single product that currently doesn't have a name and is also active on the website to Julie's product? So we can see how your queries can get a little bit complex very, very quickly. So let's talk about our next strategy, which is going to help us run these long and complex queries. So the next strategy is to write scripts and run them on our machines. And here's what this process looks like. To run scripts locally, we first start by writing the script. Then using your ORM of choice, you would convert your SQL into code. So in this example, I use SQL Alchemy and Python, but you can use whatever ORM you would like. And I usually add an argument parser to my scripts so that it makes them more reusable in the future. So for example, if I wanted to update product 2 to Julie's other product. Next, we're going to form a connection to the remote database. You can do this either using a VPN or SSH gateway. And lastly, just run the script from your terminal. In Python, this is what this command would look like. But I often like to write my scripts in such a way that I can add a dry run flag, so that way I can preview the results before I ever commit them. So what's great about this strategy? Well, the first is that unlike raw SQL, code is reusable, and you can actually, you only need to write the script once, and all you have to do is pass in different arguments. Second, you can actually really easily manipulate the outputs of the script. So when you're running it on your terminal, you can either pipe the outputs into a text file or simply into another script. And lastly, when you're writing a script locally, you have access to all of the code in your repository and on your laptop. So it's really easy for you to import functions from common code and to reuse logic that already exists. And so looking at our journey now, we have a strategy that gives us two benefits. We have the ability to edit data, and we also have the ability to execute complex logic on our database. And at this point, we haven't needed to set up any infrastructure, so the upfront investment is still relatively low. What don't we get with this process, though? Well, the first is that code review isn't being strictly enforced. So someone can actually just write and run a script without any form of code review. The second is that the outputs of the script are only available on the user's machine, and they're going to go away as soon as we exit out of the terminal. And lastly, we can run into network connectivity issues. So the script is going to stop running, say, if the user closes their computer or the internet dies out, which kind of begs the question, what am I supposed to do if my script takes a really long time to run? For example, what if I needed to run this query many times? In fact, at Spring, we have over 50 million products in our database. So what if I need to update this field 50 million times? And this is actually a really common situation that I run into on the catalog team, and I've had to do data migrations on the entire products table more than once. So when I first started working at Spring, what I would do was I would just come in really early into work and keep my laptop on all day and just like run the script from really early on and leave late at night. That was me. And this was until one day I was sitting there like this, waiting all day, and by the end of the day, only about 25% of the products table had been processed. And so I talked to my manager at the time and thinking about workaround strategies, and I was like, you know what I really need is I need a computer to be like my computer and configured with all the information that I have, except I just need this computer to be on all the time. And conveniently, we have a bunch of EC2 instances in AWS that are set up to do just that. Because after all, that is how all of our websites stay up and running all the time. So the next strategy we're going to discuss is how to run scripts on an existing server. And here's how this strategy works. Similar to running scripts locally, I would just start by writing out the script in Python. Because we're running the script on a server, then the next step is I need to get the script onto that server. And there's a lot of ways that you can do this. You can either deploy it directly onto the server as part of your deployment process. You can fetch a copy of the repository. You can upload or transfer it. For us, we compile all of our code before we deploy it to an application. So what I would usually do is I would just SCP a copy of the script from my laptop onto a remote server. And I use Jenkins as the server for which to run my scripts on because it's the continuous integration server that we use for deployments. And lastly, after the code exists on the server, all you have to do is SSH in and run it within a session. I'm a big fan of using Screen in this case. Other people like to use Tmux for their terminal multiplexer. But in general, this method for running scripts on Jenkins has gotten me through some really major projects and allowed me to go to work a little bit later and leave a little bit earlier on some important days. But there was one day, though, when I was working on a project, and I happened to see this message show up in our engineering Slack channel. Our on-call engineer, Maya, happened to notice that Jenkins was down, and so she pinged our DevOps lead, Justin, to check if it was down. And I'm a really responsible engineer, and so I, of course, immediately checked too, and I'm like, hey, Justin, it's down, she's right. And I go back to doing my work, and I was just writing some code until a couple minutes later, I had this realization. I think I shut down Jenkins. Turned out my hunch was right. It turns out that Jenkins was down because the script that I was running on Jenkins was eating up all the CPU, and as a result, none of the engineers could have deployed code. It ended up being a pretty easy fix, though. All Maya actually had to do was just reboot the instance to bring Jenkins back up, which means that running code on an existing server is still a really good strategy for running long scripts, especially if you just monitor it a little bit closer than I did, and a little bit of downtime isn't the worst thing. But it was definitely a lesson learned for me, which is I should probably look into putting into place better infrastructure. Before we talk about improvements to this process, though, let's talk about what's great about it. The main benefit here is you now have the ability to run long scripts, or really any scripts, without worrying about making sure your laptop is on. You can run your scripts inside a session and then just come back and check on it later. Similarly, because we're running the scripts on a remote server, we have the benefit of a much more reliable network connection, and we don't have to worry about things like the Wi-Fi getting disconnected. And lastly, you're getting all of the benefits of running scripts on a server, and we haven't had to put into place any new infrastructure yet. So when we look at this strategy in comparison to running raw SQL or running local scripts, what we see here is that the main benefit is we are able to run long scripts for a long period of time, and we don't have to worry about our laptop shutting off. In terms of effort, this strategy also has relatively low investment costs. So there is like a bit of DevOps configuration involved, but we haven't had to spin up any new servers. So it's still a pretty easy system in terms of effort to rely on. But what doesn't this strategy get us? So first, like we just saw, in my case, you can affect the resources that are running on your current server. So in my case, we ate up way too much CPU, but your script can also do things like take up way too much memory and trigger the infamous killer. The second is that, as you can probably tell, this isn't the most user-friendly process. The steps I described where you have to get your script onto the server, you have to SSH in the server, you have to start a session, you got to make sure your session is always running. And so this opens up a lot of room for error. And lastly, we still don't have a persistent audit trail. Sure, there's logs available on the server, but they're going to get lost once the session ends. And most likely only the engineer that's running the script can actually see them. So we can do better. Let's talk about a strategy that can automate a lot of the things I just described for us and also give us a persistent audit trail. The next strategy we're going to talk about is using a task runner. So what a task runner does is it automates all of the tasks that involved in running a script. So this includes things like SSHing into the server, setting up a virtual environment, getting a copy of the code, basically all the things that we were just doing that we want to be able to automate. And best of all, we're going to have logging built in. So we set up a task runner on Jenkins because it's what we use as our continuous integration server for builds and deployments. Jenkins also lets you write code and register arbitrary jobs, and we get a Jenkins build page that provides us with a free user interface. So similar to the last strategy, we're going to start by writing the script. Next, we're going to get our script code reviewed and tested so that it can be merged into the repository. And lastly, instead of SSHing into the server to run the script on, we can actually just do it directly from the Jenkins interface. So this is what our user interface looks like that we get free from Jenkins. You would go to the Jenkins build page, type in the name of the script that you want, select the arguments that you want, and then just click build. Jenkins then takes care of setting up a virtual environment, connecting to the remote database, and running the script with all the arguments that you inputted. And basically, you can just sit there and watch it happen. This strategy is great because it's the first one we've talked about today that gets us persistent audit logs. The logs make it easier to monitor the progress of the script, which is really useful for long scripts. Because the first step of the task runner is to fetch the latest version of master, all of the code that you want to run on the task runner also needs to be code reviewed and merged. So this means that we finally have a system that can actually enforce code review and also give us the ability to run automated tests before the scripts are run. And lastly, we can now run our scripts from a user interface, as opposed to needing to SSH into the server, which minimizes room for error. And looking at this graph now, we've come pretty far on our journey. At this point, in addition to data editing, running long and complex logic, we've also got the ability to run automated tests. We have code review, we have an audit trail, and we have a user interface. Setting up the task runner for me did take a bit of time, but when I think about my team of 50 or so engineers and how much time we were able to save as an engineering organization because we don't have to do cumbersome things like make sure we have the latest version of the script running, or, you know, oops, I made the mistake, but I don't have any logs to track it down. How do I fix this mistake? The upfront investment kind of seems really worth the cost. There's some reasons, though, that this task runner isn't getting us all the way. The first is that, as you saw in the user interface, having to input command line arguments every single time you want to run a script can get pretty tedious. And for us, that was actually the biggest driver for looking into better solutions, is because managing credentials was really hard. So after I launched a task runner at Spring, I actually found out that there were still engineers using the previous strategy of SCPing scripts onto an existing server and running them. And the reason was because some of the scripts they were running required 30 or more different credentials. And it was just a lot easier to put all of these credentials in a text file on Jenkins than for them to have to type it in every single time they needed to run a script. There's also no clear separation of environment here. So I have the room to make the error of running something against production and accidentally using some credentials from dev. That's not great. And lastly, there's no system in place here for us to verify that the arguments being passed into the script are actually accurate. So for example, if I have that script that I want to run to update the name of the first product to Julie's product, who's sitting there to make sure that I actually ran product 1 instead of product 2, or did I spell Julie correctly? And when I think about it, all of these really annoying problems that we're dealing with, they really got me thinking. We have all these problems we're dealing with, configuration management, logging, separating environments. All these problems felt really familiar, and they also felt like they had been solved before. And after all, if you think about it, all of our existing applications do this. Our web server outputs logs, all of our Python applications all share the same credentials from Puppet. So why have I been trying to reinvent the wheel instead of just building something with the tools that I already had? So I did. And the last strategy we're going to talk about today is building a script runner service. And this is how I architected mine. So an application server was set up in each environment to connect to the database that I needed to run scripts against. We also had a user interface for us to be able to interact with these script runners. The steps for running the script are pretty similar to what I had just described with the task runner. So we start by writing the script. We then get it code reviewed, tested, and merged. And lastly, the key difference here is that instead of having to input a series of command line arguments, you just pick the environment you want to run the script in and click build. And this is what it looks like to run a script with this UI. So going back to our new interface, the user would go to the user interface, type in the file path of the script they want to run, select the environment, and then click build. All of the command line arguments that we previously had to input manually, they're all going to now be available as environment variables on the script runner server. And this brings me to some of the key benefits of the script runner service. The first of which being centralized configuration management. So we now have a system for using credentials in our script that is a lot more organized than just having a bunch of drop-downs from a user interface that you're piping in. The second is that this strategy allows us to maintain a clear separation of environments. And lastly, this system is definitely by far the most user-friendly that we've seen. The amazing thing about the script runner service, though, is that it doesn't stop there. There's actually even more that we can do. So, for example, if I have 50 or so engineers who need to run scripts at the same time, we can just parallelize and scale our instances to make that possible. If I want to be able to preview the effect of our scripts on a database before committing, I can build in that functionality into Script Runner. So this will prompt me to realize things like, hey, you spelled Julie wrong, or you're updating the wrong product. And in the end, it's really up to you to customize your own version of Script Runner. So what we've seen today is there's been a spectrum of tools that you can use for editing production data. And some of you might be wondering, like, this is great, but which strategy should I be using? And ultimately, if we look at this graph, it really depends on the needs of your team and your willingness to invest in the upfront cost of the tool. So if your team is really small, speed might be the most important thing, and making a mistake once in a while might not be the worst. In which case, just having raw scripts and raw SQL and running scripts locally might actually be the best strategy for you. But for larger teams, benefits like code review, logging, testing, they're really important because you can't really have a team of 50 engineers all making an edit to a Google Doc every single time they want to run a SQL query. And you might also need things like being able to centralize all your configurations if you have tons of different servers and hundreds of different credentials. And ultimately, this really just depends on what you need for your organization. In our case, building a script runner service made a lot of sense for our needs. But the key is that as you think about moving fast and hiring and growing the size of your engineering team, make sure that you're also investing in the infrastructure and internal tools that they need to be succeeding. And this brings me to a key learning that I had in the process of developing tools for running scripts, which is when you're building something for your team, it's really important to think about safety, but it's also just as important to think about speed and usability. Because after all, the reason that we're jumping behind the SQL prompt isn't because we don't know that it's the wrong thing to do. We just do it because the cost of doing the right thing feels higher at that exact moment. And so providing speed and usability is important for building tools for your engineers in the same way that we're building our consumer applications. After all of your engineers, we're also people. And on the flip side, we oftentimes kind of find ourselves doing things that we all know that we shouldn't be doing. So we're all guilty of kind of looking at a system and thinking, this is really not ideal, or I really shouldn't do this. And then 2 seconds later, we all just do it anyways. And you should really think about investing the effort to stop doing that early on. Ideally, before you change the names of 50 million products to Julie's product. And thanks. If you have any questions or suggestions, I'll be here for the remainder of the conference, or you can reach me on Twitter at JQ25, and all of my slides will be up on Speaker Deck.
Does anybody have questions?
So how did the story end?
So luckily it's a hypothetical story in my case, but we have dealt with similar disasters at work before, and in those cases there was a lot of SQL magic voodoo happening in the background, and good backups, yes, testing your backups.
How do you manage, like, for example, with humans? So sometimes error or mistakes happen.
Yeah.
So how do you manage the rollbacks? I mean, we know in big teams we have development and also testing and production. But sometimes small teams don't manage all the cycles. So how do you manage the rollbacks?
So the question is, like, how do we handle rollbacks when we make a mistake? So I would actually say that we don't have any great processes at our company now, but I think that what's been good about, like, I mentioned, like, when I was writing local scripts, that part of it was like adding a dry run flag. So we have a pretty good, like, I guess, like, system or culture in place of, like, always test those, like, write in the rollbacks are built into your scripts. And so in those cases, it's just kind of like doing everything in a transaction and then rolling back before you're committing if you're doing, like, a dry run. In cases where we made a lot of mistakes, usually it's just more like reacting as opposed to being proactive. And part of that is actually because our engineering team has grown so much in the last, like, year and a half. So I joined when there was like 20 people. I mentioned we have like 50 engineers now, and a lot of the motivation for this talk was because in that time I realized, like, the things we were doing at 20 engineers cannot work anymore. We need better processes. Yeah.
All the kind of examples you had were dealt with data changes.
Mm-hmm.
In our application, you also have schema changes that you run some kind of migration framework that's primarily development-wise.
Yeah.
What's your technique on doing those data changes as part of regular migrations that would happen across part of the regular migration process?
Okay, so the question is, how do we do schema changes and what does it look like to do data migrations along with that? So I would say schema changes is another area where it could actually be probably its own conference talk, where we really struggled with in the last year. So in the past, it would just be the same thing as the regular deployment process. We would run migrations before, and then we put the code on. And then we realized that we ran into like problems where like if people deployed something and then had to do a rollback, it's like, oh crap, we already did the database migration, and so what do we do? And so we actually also have a separate service now that does schema migrations. And so I think the steps are probably generally to do the schema migration first, to put the code logic on top of that, and then to do like data migration things. But it's usually like a very broken out process, and we'll review it by teams before doing it. It sometimes varies by project, but in general, that's what it looks like. Yeah.
When you say testing your script, you have an environment. We take a snapshot from the database when you are doing it.
Do I take a snapshot from the database when I'm doing a database migration? We probably should, but we do not at the time currently.
Do you prefer run a long script or divide it in some other smaller
Yeah.
tests and then run with the strategy of script runner?
Yeah, definitely. So what I usually do is if I'm writing a script and we're running like 50 million products, I'll have like built-in breakpoints built into the argument parser. So I'll build in the ability to be like start at product 1 and end at product 50, or like, you know, so I can specify the start and end for the product ranges. And then if I'm running it on script runner, what I'll usually do is I'll actually parallelize it and just run like, you know, 1 to like 1 million, 1 million to 2 million, and run all of those as separate scripts so that it goes faster. And that's actually been a key benefit for script runner too, is that when I was doing it on like the existing server, I was just having like multiple sessions running, and it was like, oh crap, this session ended, and you know, what am I doing? And script runner lets you like monitor the progress as you're watching it happen live. Okay, cool. Thank you, everyone.